Hello again, folks, in 113. Today we're going to be covering section 2.3. Here's a quick glimpse of the calendar to verify. Today is Thursday, September 30th. So we'll be covering section 2.3 as per the schedule. The packet is kind of hefty. I made a lot of worksheets basically for this. So if you're following along, this first one will be annotated as I discuss it. Alright, so if you print this, take the time maybe to fill this in. This is just an example of a blank universal set rectangle. Alright, if you are doing your work in my lab and you'd rather not have to draw a rectangle from scratch, I printed one for you. Made it myself, you know. A whole rectangle, imagine that. This is a diagram. Again, I want to add to this as I go through it, so I'll give you examples of what these are indicating. All right. So it's more or less a worksheet. And here's another example of a table constructed that you could fill in unique to the problem if you'd like as a template. There is another one of my vocabulary diagrams to add to our ever-growing list of symbols. And yet another diagram. They look very similar, but they're really meant to illustrate different things. All right, you'll see when we get there. This is a new overview. I made this yesterday of different operations when we're talking about sets. All right, and I'll try to discuss these. I will. Discuss these as they arise. And if you don't like my explanation, of course, here is the segments of the section in the book that I swiped and put in the PDF for you. They're very clearly delineated. Okay, including formula. And then there's the actual examples, okay, with the solutions provided. All right. So if you're following along, do try to print that. And we'll go through this now. And I have to adjust the lights. Hold my eyes here. Kilter here. Too bad. Please. Okay. That looks reasonably placed, positioned. So maybe I'll just leave that alone. Okay. For once, I never leave it alone, right? Okay. All right. When I introduced section 2.1, so I would say Thursday last week, I gave you this overview, and it was different ways to designate a set. And at the time, what was relevant was really just these three. All right, you can designate a set by describing it. That is, sort of form a sentence about it. You could list the actual items, the elements of the set, right? Or you could use the ultra fancy set builder notation. And it's more or less an afterthought. I mentioned this in a little thought cloud here. I said, well, there's this other thing. You can actually draw a picture, because you know what they say, a picture's worth 1,000 words, right? The old adage. But I didn't go into it. How come? Because although this was relevant to section 2.1, right, what we're doing now is exactly this, right? Introducing Venn diagrams. Okay? So let's get into that. It's the old slide here. All right. That's what this is all about. All right. All right. Venn diagrams, a fourth means of designating a set, consists of these parts, if you will. To construct a Venn diagram, you would need, firstly, a rectangle, which is usually labeled U up in the corner. All right. This U that you see here stands for universal set. This isn't the kind of thing you would read in a book, but the way I always think about it is that this is more or less the box of parts or game pieces or whatever have you when you're a kid. You know, like if you've ever played a board game, you know, the board games have a lot of little, you know, tokens and stuff like them stuffed into them. Well, think of this as being the whole Monopoly set. You know, you're not going to necessarily use all of the parts, but they're in there, right? And it's confined within this little universe, right? A little teeny tiny universe unto itself. Need to put limitations on that, right? Now, within the set, within the universal set, you may designate a smaller set, right, of the whole. If this is used to represent the whole thing that you have available, then what this would be used to indicate, I'm just using A as an example, this would be used to represent a subset of the whole. It's also denoted by a capital letter. To stylize, I tried to tuck the little letter into the ring so that you could see, and make it the same color, so that you could see that, okay, this is encompassing all things that are A. Okay? In theory, I could have done that with a rectangle, but I neglected to. All right. Now, as for the Roman numerals, if and when you see them, because you don't always see them, these are used to represent specific areas within the diagram. Okay, I'm going to get into some examples that reinforce that idea. All right. A lot of times they don't even, you know, not that it really matters, but they don't have a tendency to say the word area. They say region. But I think that's intuitive. Okay. All right. So you have the whole box of parts. You have just the parts that you're using within the box. This will be superimposed. And then, for the sake of instructions, a lot of times a Roman numeral 1, to stylize it, 5, in theory that would be 10, would refer to separate chunks of the picture. Okay? All right, now let's go through some cases that would illustrate. And in that case, in that event, take a look at this diagram. Oh, well, not to double talk here, but again, if you're not up to, you know, scribbling out a rectangle, and these are perfect on my pen. You could just borrow the template that I have made here. That's why I made it available in Canvas. All right, so you don't have to actually do that every single time. Just print a couple of copies. And if necessary, if you know you're dealing with a two-set Venn diagram, you could use that template instead if you'd like. Okay, now, let me do this now. Oh, I have to move something. Let's fill in this diagram. All right, now, essentially what's going to happen is you'll use Venn diagrams perhaps to illustrate that all is in common between two things being compared, all right? This is when you're going to illustrate all in common, nothing in common, that all of one is part of the other. Or that there is essentially something in common. All right. Now, perhaps I could expand it. I don't know. If you see, or if you need to illustrate a circle that is just a single circle on the inside of the universal set box rectangle, but it is designated two different letters. So I'm just going to tuck a little A in here, and then simultaneously a little B next to it. This is suggesting, in the pictorial form, that A is exactly equal to B. In other words, the parts that comprise set A are exactly the same parts, and no more, no less, than the elements of set B. And in this event, you would refer to these as equal, right? Okay. So one circle but two letters for labeling, then you know that you're comparing two sets and they're in fact equal. Right. If instead you had this, a circle unto itself, let's call it A, and then an adjacent circle unto itself, and again we'll call it B, and they're not touching. If they're not touching at all, that means that they have nothing in common, right? They're part of the universal set because they're confined by the boundaries of that universe, but they themselves are not equal. In this instance, what you would refer to them as disjointed, if you wanted to use a technical term. A has no elements in common with B. I don't want to simply use the cross out equals because although that is true, it's not really getting at the point right now. Okay. Now there is a situation where all of one is part of the other, right? And when that happens, you have concentric circles, like tree rings. One inside the other. So you might see something like this. You'll see it illustrated as one circle and an A off to the side here. And oh, you know what? I'm going to do it the other way. It's being a little silly, but B, I'll make the outer ring. Doesn't have to be, but I have a preference for that. And then you'll see a smaller circle designated A, completely eclipsed by it, right, in theory, but it's one inside the other. What that is indicating is that A is a subset of B. And technical, equal would be a better term here, but technically these would be true subsets as well if they have exactly the same thing, same elements. Anyhow, you would designate a situation like this proper subset. Right. This symbol indicates a proper subset, meaning that it is not identical to the whole. There may be other components in here, elements, right, that are not part of A. But all of A is within B, so it's a proper subset. Okay. And then lastly, and this is probably the most famous of all Venn diagrams, I would argue, is when there's an overlap. So you would see something like this, A circled, and then a B just sitting on top of it, on a lip. And what that is meant to indicate is that this region that would be in between them, that's where the things are that are in common. Right? So they do have something in common. Right? This is overlap. This was meant to indicate that A and B have something in common. Okay, so those are the basic ideas. There are, if you've ever seen Venn diagrams before, you probably have some inkling about there's a certain phrase that goes with this. I'm intentionally holding off on saying that just yet. That's another slide, but know these four scenarios as possible pictures. All right. There's, I suppose, potentially others, but these would seem to be the most important. Okay. Okay. Now let's take a look at the situation when you have to concern yourself with Roman numerals. Which is basically the point of this slide. Okay. The situation when we're dealing with Roman numerals, and if you feel a little rusty, let me remind you again of a couple of things. Roman numerals, while not the oldest system of numerals, consists basically of these characters that you would see. You're not going to see beyond probably X. This stands for 1. It's intuitive, right? It's similar shaped at least. The V shape stands for 5. And the X shape you can kind of think of as being a V sitting on top of a V stands for 10. Okay? And so if there is any combination of these, they would probably be something in between or something just after. So for example, if you saw an I and then a V, that means 4. If you saw a V and then an I, that means 6. Right. The rule is you can only repeat 3 iterations of any one of these symbols. All right. The smaller number before the larger number means you subtract. All right. The smaller number after the larger number, reading from left to right, means that you add. Okay. So again, worst case scenario, you would see something like probably that. That would be the limit in terms of a Venn diagram. All right, so it would be 10 plus 3, which would be 13. If you were to see an I before an X, right, again, smaller before larger means that you subtract. That means you get 9. Okay? The way that this is a model divvied up. Is like so. Think of this as a model of the regions. Why bother with this at all? Because Roman numerals are not used too often anymore, so they wouldn't immediately be or intuitively be confused with the actual elements that are in the set. All right. Part of the reason why we use these letters U, A, and B is because they're capital letters and they're not numbers. All right. Sometimes you get a problem that's kind of a hodgepodge of numbers, letters, and hieroglyphic symbols, and shapes and what have you. But in general, if it's math, right, you're dealing with sets of numbers. So we used capital letters to simply distinguish the various parts of a Venn diagram, and then we use Roman numerals to designate the individual regions within a Venn diagram. So the way you would want to chop this up would be like this, as follows. 1, 2, and 3. Okay. Roman numeral 1, Roman numeral 2, Roman numeral 3. Think of these as Rocky movies, okay? Or perhaps Jaws, I think. Rocky 1, Rocky 2, Rocky 3. Rocky 5000. All right. And the region outside of these in a situation like so would be a Roman numeral 4. Right? It's just referring to the location. Right? These are locations, not elements. Right? Now, to be even more specific, let me indicate that, right, for reference. Hopefully my blue is helps the task today. What is in region number 1? All right, these are things that are just A. Right. Without scribbling too much, that would mean things that are confined to just that much area. Sort of a Pac-Man shape, if you will, right? All the way up to this edge. Confined by that, right? Would be just A. It's the one advantage to using a whiteboard here. What would be 2? That would be things that are A and B. All right. That would be the biscuit that you see here. It kind of looks like a Jesus fish. Right. Okay. 3. Things that are 3, well, think about it this way. If I1 is just A, you could make an assumption about what is 3 then. It would be just B and no other. What about 4? Four would be neither. But still part of you, the universe, the universal set. This is fading out on me. Now, to be even more technical, right, I'll put this over here. If you're talking about region 1 and 2 simultaneously, then that is all of A. Sometimes it's helpful to sort of toggle in your mind, thinking about things from one perspective versus another. Right? All of all. No, all of A. Ding dong. It's not good, effective toggling. If you were talking about two and 3 simultaneously, then that would be all of B. That's how English gets you in trouble when you're talking. Okay. If you were talking about 1, 2, and 3, and that is all of A and B. And lastly, if you're talking about, because I'm not short on space here, region 1, 2, 3, and 4 at the same time, then you mean all of you, all of this universe. I'm just stylizing the U, it should be a capital. Okay? So as I said, I purposely left this as a blank resource, so that if you write it, you'll be more inclined to remember it, right? It's not enough sometimes, especially since you guys are going into teaching, right, to simply vomit information at people. Math, they don't get anything out of it, but if you give them something, even a very simple diagram, and then sort of guide them through the process of filling it in, they're more likely to assimilate the information. Right? It's more meaningful. Right? Give people stuff, right? Especially a kid, they'll appreciate it more. Okay? There's a lot to get out of the way. I hope you will forgive me for not getting to the examples yet, but they're forthcoming. Okay. Let me go to vocabulary here. And we'll continue. There's just really 3 new symbols to worry about. So let me just maybe enlarge this a little bit. There you go. All right. So as a concept, we'll think about first something known as a complement, or the complement. And that is designated by a little sort of apostrophe. So something with a little tick mark next to it, if you will. I have squirrels. They're fighting. I don't know if you heard that weird noise. All right. Essentially, when you see this, it's a question of what is everything not whatever question mark. Whatever the letter is here. So to make that a little bit more meaningful, perhaps, if you saw this, a letter, a capital letter, to designate the unique set of something, and then an apostrophe, or I guess it's technically a tick mark. All right, everything not C. Which is kind of an odd question, right? If you see the intersection, it would look like this. Two things. So let's just say a letter A, so I'm not too original, and letter B. And this particular symbol in between, which is more or less a horseshoe shape, I like to sort of stylize it myself. You will never see this anywhere, but I think it helps to read it like so. Put a little line and then tuck in the letters N and D. It's not enough to look like the St. Louis Arch, I think. If you put in these other 2 letters, then people know that you're referring to and situation. Okay, that's important. English, it makes it is sometimes a little cumbersome when you're teaching math, so you have to take the time to specify the context in which you are saying things, or what you're meaning. Okay, unique to the situation. When you have an intersection in symbols, right, it would be more or less abbreviated this way: the set, the horseshoe shape, and then the second set. This is asking about region 2 in that last diagram. Right, that is just the overlap. All right, notice the word and when you're reading things. Right. Another scenario, when you are either looking for consciously or given a union. These are very similar looking, which is another reason why I would want to emphasize. If you have 2 sets that you are comparing somehow, and you see an actual U shape, this is not to be confused with the universal set. In the context of a sentence, you would see the word or. So either look for an and, not all of the time, I suppose, but a good indication. Look for the word or And this is essentially region 1, 2, and 3. If you've noticed, why am I using that little symbol for and? It's because I'm trying to avoid saying the word and when I'm talking about a situation that is designated by or indicated by or. This is, again, why English gets you in trouble. Different contexts, right, have to be specified. So the only thing I can do is just simply write that and maybe use that symbol for and as an idea of and, not a specific and. Everything in A and B simultaneously. Okay, so familiarize yourself with these unique symbols in sequence. All right, and know that they mean a complement, an intersection, and a union respectively. We're almost there. All right. One more diagram and now we'll get to the examples. Now, in terms of a picture, here is how a set would be indicated and a complement in relation to it. If a complement is the things that are not part of the set, then the way that this might be indicated would be a circle confining all things in A, and then off to the side in more or less region 4, Roman numeral IV, you would see A and a little tick mark. That means that the things that are here outside of the circle's limit, all right, would be the things that are not part of the set known as A. So you train yourself to sort of look at that. Right? I'm going to give you a specific example here, but I'm going to have to blow up the picture in a minute. Let me sort of complete this thought. All right. If you have an intersection, again, you'll have two circles that are overlapping. So a B again and an A again. This is when there's just an overlap that we're concerned with. That would be the little biscuit Jesus fish thing that you see here. Okay? And if you have a union, a union would be all of both. So you'd see this entire area is sort of shaded in, or you'd be referring to the elements that are confined within this sort of figure 8. Okay, let me give you an example of each of these. All right, in order to do that, I'm going to sort of scoot up the picture and then sort of use my bootleg paint to have a little canvas underneath it. The way it prints out is that there's a little bit of extra space underneath. example for this, an example for this, and an example for this. All right. Suppose, in a very non-verbal way, you are given this much information, more illustration than actual words. A, and this is A prime in this area. And you see these figures. Within the confines of the red circle, you'll see some even numbers here. 2, 4, 6, 8. And outside of it, but still encapsulated by the universal set box, if you will, you'll see some odd numbers like that. There's a couple of things that you can sort of guess at without too much of an instruction. That's the one thing that's nice about math. It is it's the universal language, sometimes they say, right? Not to use a cliche. But you can almost guess what they're going to ask you, given this much information, at least with enough practice. Right? I'm going to try to make it a little bit more clear. If U, which refers to the universal set, the whole box of parts, right, equals everything that is confined by U, which I'll put in order, it doesn't have to be, but 1, 2, 3, 4, 5, 6, 7, 8, and I really should use what do you call it, commas, but I'm not going to because I think it'll be harder to read from far away. And A is, maybe I'll put this in red to be consistent. A is the set of the evens 2, 4, 6, 8. What is A prime? A prime is how you would read A with a little tick mark next to it. Right. In other words, what are the things in the universal set that are not A specifically? In looking at the drawing, all right, you can clearly see, right? If you didn't have the drawing, if you just had the numbers to stare at, what you would do is you would cross out the things that match. So you would go, all right, well, A has a 2, so that would match in the universal set, all right? And A has a 4, so that's in the universal set. And A has a 6, so that would be crossed out. And A has an 8, right? And then the things that are left over, even without the picture to indicate, are what are not A, the complement of A prime. So you would say 1, 3, 5, 7. These are not the most elegantly expressed facts and question, right? But they get at the essence of it in a almost non-verbal way, right? If and what, right? And again, if you'd like, you can call this A prime, or the complement of A, or it's just simply what it is, not A. Right? The benefit, again, of having a Venn diagram is that you have a picture to summarize the information, aiding you in answering the question, right? But whether you have the picture or you just have the numbers involved, you can figure it out. You have to trust yourself. Right? People often do not. All right, now a situation like this, I'm going to put the numbers in first, and then we can get right to the question immediately. If you had this much information, 10, 12, reading in the dark. 14, 15, 13, 16, 17. All right. And you wanted to know what is the intersection of A and B. Given a Venn diagram and this much of a question, you could easily figure it out. All right, remember, intersection is just the overlap. All right, if we're using Roman numerals, that means region 2. All right, if you have it memorized. That region 2 is the biscuit. All right, the little Jesus fish in the making. All right, so that would be equal to what things, what elements specifically? It might be hard to see from far away and my handwriting is sloppy, but I'll tell you, it's not 10, it's not 12, it's not 13, 16, or 17, because the only part of this that is in the shall we say, the process of eclipsing, without actually going the whole 9 yards, would be 14 and 15. And I really should use a comma, all right? I neglected in these cases, again, just because I think it makes it harder to read it from far away. In this setting, you know. So 14 and 15. Okay. If you had a similar looking diagram, and you had this much inside, 10, 15, 5 and 20, and 30 and 45, sloppily writ. And the question was, what is A, U, B, understand that this particular symbol for U here is not referring to universal set. Right? It's an operation. This is an operation. Okay. And it's the symbol, it's the operation specifically of unions. Okay? So, what does a union mean? It means all of both. Right? Or in theory, region 1, 2, and 3 simultaneously. I'm trying not to spell the word and, right? So I'm using that abbreviation for it, just to say that there's a different context here. All right. So in this case, if you stare at the picture, all right, it would be a good idea in theory to put it in numerical order, but it doesn't have to be. All right, I'm going to be a good sport and put them in the numerical order. It should be the contents of this entire figure 8, if you will. All right, so 5, 10, 15, 20, let's see, and then 30 and 45, I believe. So let's see, 1, 2, 3, 4, 5, 6, yep, and there's 6 elements there. And that, I swear, is a 20. Okay. In this instance, again, just to add some emphasis, the biscuit shape in between, where they overlap, just the overlap, are intersections. When you're talking about a union, even though it's a very similar looking symbol, and this is perhaps a little bit more intuitive because it looks like a U to begin with, all right? We're referring to everything confined within the figure 8. All right. And in this case, when we're talking about a complement, we're talking about everything outside of the circle, essentially, but still confined within the box. Okay. Okay. I think there's enough of that. Now let's do some examples here. All right. Formal examples. I'll get rid of that. All right. Here are the examples that are provided by the book. They state many of the same things. I probably stole some examples from them anyway. Take a look at number 4, which has these parts and this diagram. Boy, that's a mess. To elucidate, I need to wipe it clean here. Alright, zero in on figure 2.9 apparently is how it's designated here. And we'll try to answer each of these questions. Okay, just given this picture. If I could zoom in a little bit, might be nice. That's a little bit better. Alright, determine sets from a Venn diagram, right? And this is a Venn diagramming question, alright? Remember, I know this is very subtle, and you have to be very careful when you read math books or physics books, right? Because a lot of the same letters get used, and to indicate a different context, they will stylize them in some way, which is why often Greek letters are used instead of Roman capital letters. All right. But what you see here, slightly italicized, is referring to the universal set. All right, a lot of times what I do is I try to put a little flair on it. It's the easiest thing I could do. The U that you see here is just underneath it is a U as in union, right? So this is referring to an operation instead, different contexts. Okay, so do be careful of that. All right. Let me see if I can confine myself to so much space to satiate the problem here. All right. Now, if they're asking us to designate everything that is in the universal set, right? This is one of those situations where you have a hodgepodge of different type of character, element symbols here. Don't use the Roman numerals 1, 2, 3, 4. They're just referring to a location. So in the case of the universal set, and I really should use fancy braces to indicate this, all right, it would be everything that you see in the picture, everything inside the black rectangle. So in any particular order, 8, the pound symbol is how we were taught to refer to this, but it's more commonly referred to as hashtag nowadays, right? Let me see if I can make this a little bit easy to read. There you go. Let's see. 8, hashtag, then the elements of the blue circle. 9, triangle. Then looks like a square and a circle. And then moving over would be 3 question mark, 7. And then I think that's it, right? That little arrow that you see there is actually not part of the picture. Right, so this should be everything within the universal set. It's good to establish that first because a lot of times you're asked to perform an operation given that information without a picture. Right. Thankfully we have a picture. Okay, so this is the answer to A. Right, if you put it in order of some sort, it would be 3, 7, 8, 9, question mark, hashtag, triangle, square, circle. Right, same difference. All right. It sounds like random babble, right? Big bats down to 155, over cross up the thing known as baseball, hieroglyphic, hopscotch, pouch. It was an old George Carlin routine. Let's see. Now, in this instance, part B here, we're asking about specifically set A. Now, again, the only the only point of 1, 2, and 3 Roman numerals is to indicate the region that is referring to A. All right. When you're talking about A, all right, you are talking about everything within the circle here. I'll erase it later, but what would that indicate? A would be fancy braces, all right? 9 triangle, square circle. So more shape than number. Okay. There you go. All right, moving on. All right. Now we're going to be fancy. Look, B prime or B apostrophe or B tick mark, whichever you prefer, I suppose. This is everything confined. Well, trick question. If we were talking about B, all right, then we'd go right for the red ring in this example. All right, but since we're asking for B prime, we're asking for things that are not B. So essentially, what is not B? These things are B, right? Even in the overlap, right? We want everything that is outside of this. Rather than scribble, I'm just going to refer to the outside of it. So, what is B prime? 8. Hashtag. All right. 9 triangle. So not too much. All right. Hopefully that's visible. All right. One more of these on the top tier. Now lastly, and this will be probably easier, A upside down horseshoe, B, right? This is an intersection. We've established that this is sort of an and shape, if you will. Insert A and, N and D inside of it to stylize it. All right. That would be referring to the overlapping region known as 2. So essentially the biscuit here. All right, which is just a square and a circle. Okay, not too complicated, right? Now we go to E. E is asking for a union. Again, make the distinction. That's an operation. That's the universal set. They're very slightly stylized differently, which is unfortunate, right? When we're talking about the union of these, again, we're talking about more or less this figure 8. Well, it looks like, I don't know if you've ever seen these, but if you go to an Italian bakery, there are cookies that are sort of white and slipper shaped. I don't know, my grandmother used to call them that. Sabiad, I think I'm mispronouncing it, but it's something like that. Anyhow, they're very good. They're made of almond paste, but they have more or less that shape. The things that are confined within the figure 8, 9 and triangle, square, circle, 3 question mark, and 7 in that sort of order. And you could rearrange it if you'd like it to make it a little bit more strategically organized. Would be the union, of course. Right. Now, notice what you have here. You have the union, right? But then you have the union confined within a parentheses, and then a tick mark on the outside. So this is not the union of. If we just listed all of these things that are consisting within the figure 8 union, then we have to refer now to the things that are not that, which would be just the 8 and the prime. Pardon me, the 8 and I want to call it the pound symbol, but it's hashtag is what you would call it right nowadays. Okay. Now, an interesting thing here is remember from, I want to say it was section 2.1, if not 2.2 or earlier. When you have a lowercase n, this is asking for the number of, and then whatever follows it in parentheses. The number of elements in the union. All right. So you could just physically count them, right? If we already know that the union consists of 9 triangles, squares, circle, 3 question marks, 7, count them. 1, 2, 3, 4, 5, 6, 7. All right? This is equal to 7. And that's it. There is, I'll get to it in a moment, but beware, there is actually a formula for this. There's a formula if you didn't have a picture, or you didn't do this extra work ahead of time. All right, and you'll see it momentarily. It's called the cardinality of a union. So if you're asked this question, I'll write it down here because I'm a little short on space. All right. If you were asked this question, the number of elements in the union of A and B, and I should technically say A or B, right? It would be the things that are in A, logically, the number of elements in A by itself, right, plus the number of elements in B by itself, and then the number of elements in their intersection subtracted, right? Because if you don't subtract the intersection, you would count something twice, right? So this is the overlap, subtracted out, right? As an afterthought, right? Now here's proof that this would work and produce the same figure that I just got from counting brute force. What are the number of elements in A? 1, 2, 3, 4. All right. What are the number of elements in B? This is one question we didn't answer, but it would be 1, 2, 3, 4, 5. So I would superimpose a 5 there. All right. What are the number of elements in their intersection, which again is just the overlap? 1, 2. So if you had this 4 plus 5, essentially minus 2, and you follow the order of operations correctly, which would indicate that you add first because it's on the left. All right, 4 plus 5 is 9. What's 9 minus 2? 7. Okay. It's a neat sort of alternative, if you like, the formula. Okay. All right. Let's make sure I covered all the bases here. There's my squirrels again. They're fighting with the blue jays or something. I'm not imagining it, I swear. It's like, yeah, you hear little animals making noises, sure. No, I really do. It's out my window here because I'm in my apartment, of course. It's better than hearing the clang of pots and pans, I suppose. All right, I think we're good. So, let's move on. All right, let me get to problem 7 because it will use that formula. All right, but you won't have a picture. All right, I think my thing just fell asleep. Okay. All right. If I scoot up here, and I'll sort of minimize that a bit, and you go to problem 7, and I want to not reveal all the secrets here, so I just obscure the solution for a moment. Let's reason this through. Let's see if I can darken this just a little bit more. Okay. How many visitors? Yeah. How many visitors speak Spanish or French? All right. The results of a survey of visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both Spanish and French. How many speak Spanish or French? This is sort of a segue into the conversation of unions and intersections. All right. When you see the word "and" in here, both Spanish and French, you're referring to an intersection in a subtle way, which means that this is just the overlap of these two sets of people. All right. If you're asking how many speak Spanish or French, this is referring to a union, which is all of both. All right. Now, this is a prime candidate for using that formula. The cardinality of the union. Because you don't need a picture if you have the formula. This description of the set situation is enough. All right, I'm going to put it here again. And hopefully this will be visible. If it's not, I'll adjust it. So, if we're asking about how many, right? How many is the number of, right? In a different phrasing. This actually writes nice today, the green. Right? The number of. So, n in this union. The number of the union of Spanish and French speakers, essentially. Don't be, I know you might, any person who has never seen something like this before, and especially if you've been convinced wrongly that math is not your forte, right? You may not be as daring as I am being right now, which is to rephrase the sentence, all right, and then to take a little artistic license, all right? That's a hurdle that we all, humans, we have to overcome, all right? You're no less capable than anybody else, all right? So, how many speak? The number of. The word "or" here, the union of Spanish and French speakers. So, that means the union of, let's just use their capital letters, S-U-F. The number of Spanish, the number of the union of Spanish and French speakers, or is the phrase I should be using. Right? That equals the number that are simply Spanish speaking people, plus, logically, the number that are French speaking people, logically, and then just to make sure that we don't cover our own tracks here, we would subtract out the number that is in their intersection. Right? If you feel a little sketchy, right, remember you have this formula to fall back on, right? It's only true for finite sets, but it's, you're not going to really have to worry about it in any other situation. So, let's pluck out the necessary information. I hope that this is visible. I think that's a little bit better for the camera. Right, like that, ironically, with the sun coming in. Alright, so to answer their question, how many people are French or Spanish speakers? The number of Spanish speakers, it is stated, is 25. So I'm going to superimpose 25 here, right on that part of the formula. And I know I have to add. How many people are French speakers? Alright, it's a little hard to see, isn't it? 14. Good that I use blue, right? Vive la France. Alright, so plus 14. I mean that sincerely. My family is French Canadian. Alright. Alright. Also, I have fond feelings for the Statue of Liberty, as anybody should. Alright. So 25 plus 14. Alright. And then again, because we don't want to count something more than one time, more than once, what we must do is take advantage of the information that was volunteered to us, which is that there are 4 that do both. That is the intersection. So, minus 4. Right? Essentially, it's 25 plus 14 minus 4. This much would be how much? 39. All right, and if you subtracted 4, and you should do it in that sequence, right? it's 35. Right? So 35 speak either Spanish or French. That's cool. All right. Let's see. Let me show you the overview diagram now that I have made, as I think it's worthwhile. Of course, I did make it, so I would say that, right? Minimize this. Take a look at this. It's meant to summarize a lot of these things at the same time. And now let's do the light just a bit. Here you have different set operations. And you normally like to put this at the top of the page, but in order to fit all of this information and sort of the hints here, it ended up working out that this was here. So I didn't fight the way it flowed. All right. Firstly, there are these set operations that you'll have to deal with. All right. Complements indicated by a prime tick, perhaps apostrophe mark. All right. Unions you're familiar with, intersections you're familiar with, regular subtraction, essentially, and then something called cross product, which is not quite the multiplication you think it is. All right, it's literally crossing things. All right, so let's start with complements up here and sort of go clockwise. All right. I know that I have it listed that this is kind of furthest left, but I'm going to start from the top left corner. What you see here is the is that visible? Looks like it's okay. What you see here in the more or less complement corner is the set builder notation. The fancy, ultra fancy way of referring to this concept. All right, A prime, all right, is the set of all x's such that x is an element of the universal set. I very much intentionally tried to stylize the u because I don't want it to be confused with the union u. All right, and x is not an element, cross out of the lunated epsilon, the set A. Right? So in other words, it's part of the whole, but it's not anything from this particular part. Right? Now, if you want to, if you don't have a picture, but you just have the numbers staring at you, all right, this is what I would do. All right? Cross out the matches that you see between the universal set and the set of A. All right? And then keep the leftovers. All right? The leftovers would be everything not A. Right? Kind of did that earlier. Right. Now, if you look over here at union, which is tucked in the middle here, here is again the set builder notation, the ultra fancy way of referring to this idea. All right, and then here's a suggestion in green of how you might go about it. All right. What is the union of A and B, all right, is the set of x's such that x is an element of the set A, or, and I purposely capitalized this because of the context that is associated with union, all right, x is an element of B. All right, so it's the figure 8 in the picture, but if you don't have the actual diagram, all right, then even if you just have the elements staring at you in the face, all right, look for basically accounting everything just one time, right? Right. So account for anything that you see in the figure 8, all right, just once, all right? All right. it is referring to all of both of these things at the same time. Right. Now, when you get over here to intersection, right, really the best advice I can give anyone is to think of it as being the overlapping area. All right. If again you don't have a picture though, all right, here is the ultra fancy set builder notation. All right. The intersection of A and B is the set of elements X such that X is an element of A, and in the context of intersection, X is an element of B. All right. All right. I really want, when you see this symbol, to associate that word with this concept. All right. As an English speaker, you know, I can personally attest to words having double meanings, and sometimes they have similar meanings, but they really shouldn't be conflated, which is to sort of blend meanings together simultaneously. All right. So the way that I'm trying to sort of emphasize that this is a specific context of intersection that you should sort of like visually look for is I've capitalized it. All right. All right, so again, that's the intersection. Now, what do you do when you just have the numbers or characters or elements or items staring at you in the face on the page? All right, cross out whatever does not match, all right, and then keep what does, all right, and that will give you essentially just the overlap. So in some instructions, you're crossing out what does match. In this instance, you're crossing out what does not match for intersection. Now, let me go over here to, there's that cardinality of union formula again, if you'd like. Difference. I'm going to back this off a little bit. When you're talking about a difference between sets, here again at the very bottom of the page is the very fancy set builder notation. It would be the set of A elements minus the set of B elements, right? A minus B is the set of X's such that X is an element of A, and at the same time, all right, slightly different context, I suppose, all right? It's not important really. X is not an element of B, all right? What this is essentially indicating is that you're going to cancel out matches from A. Right? Right. So it's different from complements, because when you're dealing with a complement, you're dealing with things that are not A to begin with, right? When you're dealing with a difference, in reference to A, right, you're just taking away the things that are in common with some other set. So to get around this, all right, here's basically what's going on. You're going to keep only from A, there's still A things, all right, what isn't coincidentally in B, right? So isn't also in B, right? How to do that without sort of being on automatic pilot, all right? Cross out the matches first. And just because this is obscured, humor me a minute. All right? Circle the leftovers in A. Keep these only. All right? So you've crossed out the things that match, but you're keeping the things that happen to be in A, all right? You're not keeping the things that are not A, because that would be a complement. All right? Okay? It takes a little getting used to. All right? Again, the reason why I just wrote the word and in lowercase here and blacked it out rather than kept it in purple is because it's really not relevant to what we're thinking about here, right? Right? When I put it as a capital and over here, it's because I'm really trying, and I made it purple to match, I'm really trying to get you in the habit of going, okay, this is referring to this, right? The overlap. If you think about it deeply, perhaps it's okay to say it either way, all right? But to me, I'd rather not dwell upon it. I think it's more confusing than it's worth, all right? All right, so, if you know you have a difference, cross out things that you see are the same, all right, and then circle the things that are just in whatever is the first letter, all right? So the order definitely matters in the case of ordinary subtraction anyway. All right, now lastly, you have something called the Cartesian or cross product, and we use the multiplication symbol, all right? Now, under ordinary circumstances, multiplication would in fact be commutative, right? Which means the order in which you do things doesn't actually matter. But as you can see, there's a cross-out symbol here, right? These are not commutative. Which means what? It means order matters. If they're not commutative, then you're going to get two different answers, depending upon whether the A is in the front of the symbol, the operation, the operator, or the B is in front, reading from left to right. Okay? All right, so just beware of that. Ordinary multiplication, yeah, they're commutative, but set multiplication, cross products, make it distinct, all right, is not commutative. So the order very much matters. You should expect different answers. What is essentially going on here? It's sort of like forming coordinates, all right? So you're going to form like, instead of having a list of individual elements, you're going to have a list of ordered pairs, all right? Now, the easiest thing I can tell you to do is basically this, all right? Draw arrows, all right, from A elements connecting to B elements, all right? And then pair them together in each their own little parentheses separated by a comma to be very official, right? Technically, these are referred to as ordered pairs, even if they're not dots on a coordinate plane, okay? How would you read this? The cross product of A, B is the set of all ordered pairs, x comma y, such that x comes from the elements of A, and again, the context is not important about intersection really, even if it does work out. Y is taken from elements of B. All right, so you're going to get your x portion of the thing that's written in front, specifically from the A's, and you're going to get the y's specifically from the B's. Okay. We'll do some examples to illustrate each of these concepts. Okay. Now, last thing, I'll back this off. I did throw in the formula that I mentioned earlier. Cardinality of a union, the number of elements in the union of A and B, two sets, right? It's everything from A by itself, everything from B by itself, and then subtracting out their overlap so that you don't count things twice, right? Same pertains to just finding the union, the actual specifics of it. You just count for anything one time, once. All right? So let's do some examples. Go back to this. All right, B is a very similar, pardon me, 8 is a similar question. So let me go to this. And we'll get through this. Come on. Where's my bootleg paint? There it is. Alright, here's all the parts that we're going to work with here. And we're asked to find the difference in each of these contexts here. arrangements, right? We have, firstly, the universal set, the whole kit and caboodle, all the parts in the Monopoly box, right, whether we use them or not. The A portion of it, the B portion of it, and then the C portion of it, right? If you analyze A, B, and C, they're all the things that would be in the universal set, right? Now, if we're going to find specifically the difference of A and B, let me see if this helps. I don't think it helps. Okay, maybe back here. Always trying to find the light just right. Okay. Remember what we're going to do. I'll just sort of, without flipping my slides around, let me just point at the overview of the printed copy I have here. If we find the difference, all right, we're going to cross out the matches, and then we're going to circle the things that are in the, whatever it is, the first letter here. All right, so let's look specifically at A and B, things that you see here. Let's cross out the matches. That's step one. Okay. They have a B in common. They have a D in common. And they have an H in common. All right. And since we're considering things from the perspective of A, that has taken away the matches, it is technically their overlap, so technically and is appropriate. All right, now let's just circle leftovers in A. This A was written in front of the subtraction symbol. That's this. That should mean that the set that is the difference of A and B in this particular order is E, F, G. All right. I didn't move my papers. Very nice. Okay. If you did the same thing for A and C, right, it's the same process, right, because we're still considering a difference. I hope I didn't erase this upside down. You know how you hold an eraser a certain way? I think the last time I did this by accident. Okay. Still the same process. Cross out the matches, circle what is left over. All right. What matches in A and C? All right. They still have a B in common. They have an E in common in this situation, and they also share a G. All right. So we would just be interested in the things that match in A, which means that in this scenario, A subtracting out the things in common with C, all right, would be D, F, and H. Okay. All right. Moving on. Now we have A prime minus B, right? A prime is not one of the sets that are given here, so we would have to figure it out, all right? So the first thing is determine A prime. That is the complement, things that are not A. There's quite a lot of things that are not A. All right. So in that case, what could we do? All right. Cross out the matches in the universal set. So you're really going to pay attention to these two first. All right. In that case, cross out matches in the universal set. Is that visible? Looks like it is. So, A and B have that much in common. D, they have in common. Right. Pardon me. Set A has B in common with you, and D in common, and E in common, and F in common, and G, and also H. All right. So, now we're going to circle what is left over. Right? keep the leftovers. I should specify the leftovers that are in U, but it's kind of intuitive anyway because U is always going to, A is always going to be a subset of U, so you're not going to have anything to circle in that. All right, but what do you have? You have A, you have C, I, J, and K. All right. So to add to this list here, A prime, the complement of A, things that are not A, is equal to A, lowercase, C, and I, J, and K. Now having done that work, I'm going to clean this up, not to get distracted, and zero in on these things that are relevant. The thing that I've just determined, A prime, and what is being subtracted, which is B. Right? In this situation, remember, what are you going to do for differences? Cross out the matches in reference to these two now, right? Which is A, and B is okay, D is okay, H is okay, and I has to go. And then what we should get as an answer is this. Circle the leftovers in A prime in this instance. It would be C, J, and K. Okay. All right, now for D, again, it's asking us about C prime, or the complement of C, or simply the things that are not C. And that's not given to us, so we have to determine that first. Right. We would have to determine C prime, all right, things not C. And I'll put it up here. All right. Zero in on U and C for right now. We're going to cross out the things that match in U and then keep the leftovers. So B, E, and G. And that means there's quite a lot of things that are left over. A, C, D, F. I'm sorry, my shadow is blocking it. H, I, J, and K. A, C, D, F, H, I, J, K. Okay? And now, again, from the perspective of A written first, right, we're going to cross out the matches and then circle the things that are, in this case, left over in A. So zero in on these two things. B is okay. D looks like it's going away. F is okay, pardon me, E is okay, F matches, that goes away. G is okay, but H has to go. Alright. And we circle the things that are specifically in the first letters set that is left over now. So B, E, G, alright, looks like. B, E, and G, beg. Okay. Now let's do an example of the cross product, which is the most alien, perhaps. Basically, again, we're trying to form coordinates. Ordered pairs would be a more appropriate way of referring to them. We're not going to bother to plot anything, of course, but if we were talking about ordinary numbers, in theory, it could refer to that. All right. Now, if you read A, It says, given A is equal to orange, banana, apple, and B is equal to 1, comma 2, determine the following. A cross B, B cross A. These will be different answers because, again, it's not commutative, even in spite of the fact it looks like multiplication. All right, A cross A, and then B cross B. Right, let's try. All right, let's start by writing these things adjacent to each other. So, in the case of A, it's orange, banana, distant, and apple. And B, much shorter, is 1 and 2. All right. Remember these instructions. All right. If you're looking to form ordered pairs, all right, try to draw arrows connecting A things, A elements, to B elements, right, and then listing them in a little parentheses separated by a comma like this. List them as coordinates, if you will. Ordered pairs is the more technical way of referring to it. All right. So that's colloquial. All right. So each A to each B in that order. Orange 1. A little comma. Okay. Orange 2. Banana 1. Banana 2. Right. Apple 1. Apple 2. Meanwhile, if any of your relatives happen to be around while you're watching this, they're probably going to go, this is what you went to college for. You're talking about fruit and numbers. Shame on you, right? I swear, there's a reason for this. It's just a strategy. All right, now, technically these would be encapsulated in fancy braces, and they would be, in fact, extra commas here. I'm going to choose not to put those commas because I really don't want you to confuse them with the commas of the ordered pairs. Okay, but as you can see, all right, this would be the order if it's A in front and B following it. Orange 1, I just shortened it, right? Abbreviated. Orange 1, orange 2, banana 1, banana 2, apple 1, apple 2. All right, that is for this situation, right? A cross B specifically. All right, let's do the other one, and then I'll probably just call it quits here. Let's try it the other way because it might be interesting. Technically did it already, but let me erase my little lines here. Just to emphasize the point that it's not commutative. Right? Commutative. All right. If you're dealing with this situation, now, situation B, B is in front. So if you're gonna draw these connecting lines, all right, these arrows to help you arrange this, all right, start from the B elements. So you're gonna go backwards, all right. So this would be 1 orange. All right, and then 1 banana. And then 1 apple. move on to the next element in B. Right? So you'll now start with 2 orange. As you might have guessed, 2 banana. And then 2 apple. 2 orange, 2 banana, 2 apple. Okay. As you can see, not to cheap out here on you, if you were going to do A cross A, you're going to get you'd have to write the same set twice, and then just go through the process of connecting arrows, right? So what you would have is, you could see here, the A cross A, orange, 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 banana, orange, apple, right? And then it begins with banana, orange, banana, 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 apple, right, and so forth. Okay. Again, the best advice I can give anyone is physically draw arrows connecting the A elements to the B elements, right? And then list them as ordered pairs. One thing I neglected to do, and I should have, is remember, encapsulate all of this once you're done in fancy braces to justify it as a set. And technically speaking, all right, there should be commas in between these ordered pairs. All right, I've neglected to do that a lot today because I just think it makes it a little bit harder to see in my scribble from that distance with a camera and this weirdo lighting that I have. Okay, so let me turn this off. And I'll just remind you what we're doing. For homework, if you're following along, again, do try to keep pace. All right, do section 2-3 in my lab. All right, I had to do early warning grades, just I'm obligated to. They're not set in stone, so I don't want anybody to panic. All right, I just based it upon whatever your average was at this point. So by the end of the semester, you'll probably be okay, but just make sure that if you've missed any assignments, don't do that forthcoming, all right? And then when the final rolls around, you want to really prepare for that. Anyhow, don't take your time with it. Don't try to, do everything at the last possible second, because, you may get it done, but, how much of it did you actually assimilate, all right? It's important to do this over the long run. That's how you learn, all right? Okay? There's not going to be an 090 video this week because we're not doing anything that's algebra. All right, so I'll see you again on Tuesday. Be careful out there.